are able to sense things through electroreception. Very neat adaptation that they have. Has anyone ever heard that a shark cannot stop swimming or else it can't breathe? Have you guys heard that before? So that's not entirely true. A lot of sharks do have to keep swimming to keep oxygenating their gills, to keep water flowing over their gills. But some of them don't, and our rays don't either. And that's because they have one really unique external feature that a lot of sharks don't have that forces them to have to continue. And it has to do with these two holes right behind the eye. Right here and there. Does anybody know what those are called? No? Good guess. The nostrils are on the bottom. But they do kind of look like nostrils. Those are called spiracles. And they allow them to pump water over the gills while staying still. So rays like to bury themselves in the sand, as I mentioned before, and this allows them to stay in that positioning and wait in hiding to protect themselves or to ambush predators, depending on what their feeding strategy is, without having to worry about moving to keep oxygen flowing over their gills. Last thing I think we'll go over external anatomy-wise with this one is custody of the tail. Is this a stingray? Who thinks it's a stingray? Yes, hand up if yes, it's a stingray. And hands down. Hands up if no, it is not a stingray. For those who think it's not a stingray, why do we think it's not a stingray? You what? Doesn't have a long enough tail. That is a really good guess. Yeah. Did you have any thoughts on that? Nope, you just don't think it is one. Yes. It doesn't have a barb. Correct. So it does have to do with the tail. So two butterfly rays are notorious for having very short tails in general, so that's a really good observation. Great. But the main reason they are not a stingray is because they don't have a sting or a barb. Do you have a barb out today? Totally fine if not. But if it's a stingray, a true stingray, it will have a barb or a sting at the base of the tail here. And these guys don't have that, so you don't have to worry about them stinging you. They're pretty calm, cool critters. Another difference between them and some other guys that look like them, this is a ray, and we also have two different octopus. So here's an example of a stingray barb from a really big stingray. This guy doesn't have that. You watch him. We also have skates that look very similar to rays without barbs. They don't have barbs on them either. Abby's holding up a skate for you to see over here. No barb on the tail. One of the main differences between that and just a regular ray is their mode of reproduction. So these guys, skates, they will lay eggs for mermaid purses that you may have seen washed up on the beach before. Whereas our rays typically give live birth to their babies. So that's a distinguishing characteristic between them and the other kinds of Alaskan rays that also don't have stings or barbs. One last thing I just thought of that's pretty cool about the butterfly ray is this hunting strategy. Does anyone know how butterfly rays get their food? Does anyone have any guesses either? Yeah.
Well, I see the long fins, so maybe like
That's exactly correct. He said he noticed the long pectoral fins on the butterfly ray. So maybe like a thresher shark, which if you guys don't know what a thresher shark is, it has a tail that normally makes up over half of its body shape. Very long. And they use it like a whip to stun their prey underwater. Very similarly, our food butterfly rays will use these large pectoral fins to smack fish out of the water. And once it smacks them and stuns them, they will gobble them up. And it's easy to eat. So these guys have a really interesting hunting strategy as well. Alright, so now I'm going to go ahead and walk you guys through how we would work up a ray if we got it on the boat, and then I'll move into our internal dissection and anatomy after. So when we get a ray or fish of any sort on our boat, we try to collect as much data as possible from that fish. And one of those things is taking measurements. Now in a shark or a bony fish, it's maybe easier to figure out how you would measure that, right? Head to tail. With this guy, shaped a little bit different. So we would do what's called a disc width ray. So a disc width consists of holding the transect tape from one side of the pectoral all the way over to the other. And so then I would tell the person that's on data, we want to record the disc width as 622. So we do all our measurements in millimeters. And so we would get a disc width of 622 on that guy. And then we move on to our rest of our sampling. And that consists of also getting a pin clip. A pin clip is like a tiny little snip that we'll take out of one of the fins of the fish. Doesn't hurt them. It's just like taking a tiny little skin sample essentially. And we'll do that to collect DNA from the fish. We can tell really interesting things from the DNA, like the paternity of it potentially. We have pups associated. We can look at lineage or kinship, if you will, of the fish. And we can also do a bunch of other interesting genetics. So now, I will show you how we do that once we cut it open. Right? So we will, on a rig, only take a fin clip from the base of the pectoral fin, or the base of the pelvic fin, or one of the tips of the pectoral fin so we can't access that very easily. So I will just take a little snip like this. Just a tiny little piece like that. And then we will put it in a vial for storage. And after that, we'll process it in the lab. Alright, just getting my hair out of my face before we get dirty and put this over. Alright, so that concludes most of our external workups that we'll do with this. If it was a male, we would also do some measurements of those external clasper reproductive organs that I was discussing earlier. But since we've got a female, we won't be doing that today. You have a question? If it's mature, so if it's a male, we're able to do that externally.
Let's not go live
There's 3
when she
criteria.
starts cutting.
The claspers have to rotate 180 degrees.
I don't know.
The claspers also have to be fully calcified, which means hard for the full length of the clasper. And the rapidian, which is a spur-like structure at the end of a clasper, has to splay open. This one doesn't want to splay. It's also been fixed with preservatives, so that probably has a lot to do with it. But if it meets all 3 of those criteria, then we know it's a fully mature male. If it meets only a few of those criteria, then we know it's a transitional male, or it's in its teenage years, teenage era. And if it meets none of those criteria, then it's an immature male. Now with females, we actually can't tell what maturity they're at without cutting them open. And even so, it can be kind of difficult to decipher sometimes, but we look for things like eggs internally, and if we see eggs that are ready to be fertilized or have been fertilized, then we know that that female has reached sexual maturity or is an adult. So we'll see if we can see any of that when we cut this guy open, or this gal open rather. All right.